welcome to 3.3 derivative shortcuts. Today we are finally going to ditch the limits, the old, long, drawn-out way to find a derivative, and we're going to talk about some shortcuts. And these shortcuts will make your life a lot easier, but they are super important to memorize them all so that we can use them really throughout the rest of the year. I do have a helper today, and this is my daughter here, Lauren. Do you want to say hi, Lauren?
Hi,
Scoot over a little. This way, yeah.
Hi, I'm Lauren. I just wanted to say I was wondering if you were having a good day, and I wanted to just tell you good luck on your math.
Thanks, Lauren. She might help us out a little. So we have a few rules that we're going to use today to help us do derivatives a lot faster with these shortcuts. The constant rule, the power rule, the constant multiple rule, the sum and difference rule, and the product rule. We are going to save the quotient rule, which I think is the toughie, for the next screencast. So here we go. Let's go one by one. The first one here is the constant rule. And here we've got a f of x equal to a constant, some number. And when we have a function equal to a constant, it is going to produce a graph that is like this, which is a horizontal line. In this case, the function is equal to 4, which gives us a horizontal line at 4. So now, when we talk derivatives, we should be thinking in our brains about slope. And if we think slope of a horizontal line, what is the slope of a horizontal line? 0. Any horizontal line is going to give us a slope of 0, which means that the constant rule tells us that the derivative of a constant is always equal to 0. No matter what that constant is, you're always going to get 0. No limits necessary. It's just what's going to happen. Okay, so rule number 1, constant rule, remember that. Second rule. Okay, Lauren, you got to scoot over. Thanks. The power rule. This one we've got a variable x as our base raised to some power. And in this case, I'm just going to go with a generic n, and then I'll do some examples here in a minute. If you want to see the proof to this, I'm going to make another screencast here today, and you can I encourage you to check it out, and that way you can see how and why this rule is what it is. But the shortcut, and I encourage you to put this in your notes. You probably should take notes as you watch this so you can reference it later. The shortcut, the derivative of a power situation, is n times x to the n minus 1. And once again, if you want to see the proof, go back to the website, and you'll see another video there with the proof. And here's what happens. This exponent, whatever it is, becomes the coefficient. That n moves down in front, becomes the coefficient, and the power reduces by 1. Let's do an example. For example here, I've got f of x equals x squared. My power rule tells me that this is going to become the 2 is going to come down, and the power is going to reduce by 1. So instead of 2, it is now a 1, which is just 2x. So let's talk a little bit about what that means. So if I go back to my graph here, and this is the graph of the original. This is the graph of f of x. F prime of x, if you recall, is telling us the slope at any value of x. So for example, x squared. If I look at 1 and I think tangent line here, I plug in a 1 here and I get f prime of 1 is 2, which tells me that the slope at 1 is 2. Looks about right to me. In a minute, not right now, okay. And now let's say I look over here at negative 2. Negative 2, if I think tangent line and I think slope, f prime of negative 2 is equal to, plug in negative 2 here, I get negative 4. And remember, we're talking slope here. So that's telling me the slope at that point is negative 4. And you can plug that in for any point. It'll give you the exact slope at any point. So that's the power rule. We use that one lots. Constant multiple rule. This is kind of a combination of some rules here. And what this one states is that if you have a constant out front, you can just separate that, take your derivative of the other piece, and then multiply. So for example, what it means is that I can take the 7 times the derivative of x to the 5th, which we know now, because of the power rule, is 7 times the derivative of x to the 5th is 5 x to the 4th, which gives me a nice, neat 35 x to the 4th. And here's what I do when I'm thinking my way through these. I just leave the constant there. I bring the 5 down using the power rule and multiply in my head. 7 and 5 is 35. Reduce the power by 1, and you got yourself your derivative. Now keep in mind that this derivative is giving us the slopes of the original function at any point x. Hey Lauren, can you let Derby in? Thanks. My dog's crying. Let's move on. Sum and difference rules. Easy stuff. If you've got a sum or a difference, all you need to do is look at each piece on its own. For example, here I've got 1, 2, 3, 4 different things being added or subtracted. I'm going to look at each one on its own. I'm going to do this one first, this one second, third, and fourth. Okay? So if I do the first one and I think power rule, I get negative 6x squared plus, here comes the second one, 8x. Here comes the third one, minus 7. The x is gone because the power 1 gets reduced to 0, which makes x to the 0, which is just 1, which leaves us with just a 7. And then we learned with our constant rule that that is going to become a 0, so we are done. That gives us the derivative of f of x. This one here is going to be a little bit trickier. So I'm actually going to rewrite this thing first, because I got some weird stuff going on. First, I'm going to pull this 2/5 out front. Second, I'm going to rewrite this x squared on the bottom as 3x to the negative 2. And I'm going to rewrite this radical as an exponent to the 1/2. And now what I'm going to do is I'm going to move this down. I'm going to run through a bunch of power rules. And if I go power rules on this thing, the 3 comes down. 3 times 2/5 is 6/5 x squared. Same thing here. Negative 2 comes down, plus 6x to the negative 3rd. And we do the same deal here, but we work with fractions now. The 1/2 comes down front, and the 1/2, we subtract 1 from that to give me a negative 1/2. Now at this stage of the game, leave it like this. In the next few days we're going to start talking about simplifying these, getting rid of the negatives, but for right now I just want to make sure we know the rules, and that is our derivative. Let's move on. Last one here, well, not quite last, but close to the last one, is the product rule. And this is a biggie and probably will be the toughest one of the day. And here is the general equation for the product rule. And you'll have to use this whenever you're multiplying two things. Okay? When you're multiplying two things, your two things are going to be like a u and a v. Okay? A u and a v. So, for example, like this one here, this would be my u, and this would be my v. U times v. And the pattern that we have going here is, in order to get the derivative, this is what I always think in my head. This represents the derivative of u. This here represents the derivative of v. So in my head I think this. Derivative of the first, meaning u, times the second, plus the derivative of the second times the first. That's what I kind of think my way through. So here we go. If I do that, I think in my head, derivative of the first times the second. plus derivative of the second, which is going to be 4x, times the first. And I am going to do a little bit of simplifying here. I'm going to distribute minus 15x squared. Distribute here, 4x to the fourth plus 8x. Looks like I can combine a couple of things here. 10x to the fourth minus 15x squared plus 8x. Done. That's my derivative. That's my y prime or my f prime of x, either one. dy dx, it's all the same. But that's the pattern. Derivative of the first times the second plus the derivative of the second times the first. Simplify, go from there. Now I do realize we could FOIL this right off the bat. If you FOILed it right off the bat, you could just run through the power rule, and I admit it is a lot easier to do it that way. But we will soon hit some functions that it just doesn't work. Trig stuff, other stuff, and it's important that we know the product rule. So you're going to need to know how to go through this step-by-step pattern. Okay, so you'll get practice on it Monday in class. And the very last thing I want to talk about here is higher order derivatives. Higher order meaning more than one derivative. Y prime, dy dx both mean first derivative. Y double prime equals dy squared over dx squared is your second derivative. So for example, y prime here would be 12x squared plus 4x minus 6. And my second derivative here would be, run through the whole thing again, 24x plus 4. And I suppose I could go even more. Third derivative, 24. Oh, let's just finish it off here. The fourth derivative would be 0. And we're done. That would run you through all of them. That's it. That's the beginning of our derivative rules. We've got more coming tomorrow or later this week. We're going to practice these quite a bit because these are important for the rest of the year. So please bring questions tomorrow and be ready to do a bunch of these and see if we can get good at them. Okay? Thanks. Have a great weekend. Lauren, do you want to say anything? Okay, come on up. Guy, look in here. Say bye.
Bye, and I just wanted to say something different too. Listen to your teacher and do a great job.
I love it.
Bye.
Good directions. She's awesome. All right, thanks. See you guys.